For t is greater than or equal to 0, the position of a particle moving along the x-axis is given by this function here, x of t. What is the acceleration of the particle at the point where the velocity is first equal to 0? So we need to find the acceleration of this particle whose position function is given by this x of t equation here. And the acceleration we need to find is at the point where the velocity is first equal to 0, meaning the velocity function is equal to 0. We need to find what the value of the acceleration function is at that point. So let's find where the velocity first equals 0. So we have this x of t function, which gives us the position of the particle. And in order to find the velocity, we need to take the first derivative of x of t, because the derivative of the position function gives us the velocity function. So let's take the derivative of this. The derivative of sine t is cosine t, and the derivative of cosine t is negative sine t. And since there's already a negative here, it cancels out, and so we're left with sine t. So now this is our formula for the velocity of the particle, and the question asked us to find the acceleration at the point where the velocity is equal to 0. So let's find the point where the velocity is equal to 0 by setting this equal to 0, this cosine t plus sine t. So let's rearrange this, and by moving the sine t to the other side, so we'll have negative sine t on the right-hand side. So we need to find the value of t when cosine t equals negative sine t, meaning cosine is equal to the negative of its sine. So I have this unit circle here. You won't have the unit circle on the test, but because you'll have to memorize this, but we'll just use this as a reference for now. Normally you just memorize this, but cosine t is the x value and sine t is the y value in the unit circle. And the first instance where cosine t equals negative sine t, starting from 0, is at a t value of 3 pi by 4. Because when the angle is 3 pi by 4, the argument, or t, in the cosine and the sine is 3 pi by 4. Cosine is negative root 2 over 2, and sine is root 2 over 2. So that means they're the same values, but opposite signs. So when cosine t is negative root 2 over 2, sine t is root 2 over 2, and the negative makes them equal. So this means our t value is 3 pi by 4. Now obviously you could keep going around the circle, and you could even just add another 2 pi to this angle here, or go into the fourth quadrant and use 7 pi by 4. But the question asked us for the point where the velocity is first equal to 0, meaning the smallest value of t where this is first true. So obviously starting from 0, this is the first time where cosine t equals negative sine t. So now we have our value of t where the velocity of the function is equal to 0, because we just solved this function for t when v of t is set equal to 0. So we need to find the acceleration at this value of t. And to get a formula for the acceleration of a moving particle, we need to take the second derivative of the position function, or the first derivative of the velocity function. The second derivative of the position function is equal to the first derivative of the velocity function, because obviously the velocity function is equal to the first derivative, so taking another derivative makes it equal to the second derivative of the original function. And we know that the acceleration is equal to the derivative of the velocity, or the second derivative of the position. So let's take this velocity function and take its derivative. So the derivative of cosine t is negative sine t, and the derivative of sine t is cosine t. So now this is our acceleration function, and we need to find the value of this when t equals 3 pi by 4, because that's when the velocity is first equal to 0. So what we need to find is a of 3 pi by 4. And we can do that by just plugging in t equals 3 pi by 4 into this equation. So we need negative sine of 3 pi by 4 plus the cosine of 3 pi by 4. We'll do it here. Okay, so the sine of 3 pi by 4, we can use the unit circle, but you should have this memorized. So the sine of 3 pi by 4 is equal to root 2 over 2. And we'll put a negative on the outside, so there's a negative here. And then the cosine of 3 pi by 4 is equal to root 2 over 2. Negative root 2 over 2. So we'll have a negative root 2 over 2. So this is just going to become negative root 2 when we add these two together. So this is the value of a of t when t equals 3 pi by 4. Because at this t value, v of t equals 0, which is what the question asked for. The value of the acceleration when the particle has a velocity equal to 0. So negative root 2 is the correct answer. So A.